Comparing the viscosity of polar and non-polar substances. The substances used in the observation were water, canola oil, and ethanol. This observation was carried out in the following way. First, a measuring cylinder was filled with 100 milliliters of canola oil, placed right up on the bench. Then, a metal ball was held just above the 100 milliliter measuring line in the cylinder so that the ball was fully submerged. And finally, the ball was dropped, and the time taken for it to fall to the bottom of the cylinder was recorded through video editing software. This was repeated with ethanol and water. The oil had the slowest drop time of about half a second, followed by ethanol with 0.17 seconds, and the fastest drop time was water with 0.14 seconds. Therefore, we can conclude that the water was the least viscous liquid, followed by ethanol, and finally oil, which was the most viscous in comparison. Why is this the case? To answer those questions, we need to look at water, ethanol, and oil at an atomic level. Viscosity is the measure of a fluid's resistance to gradual change in shape by stress. In the observation, before a falling ball reaches its terminal velocity, gravity is equal to buoyancy and drag forces. This drag arises from liquid molecules reorganizing around the ball's surface. Strong intermolecular forces resist reorganization, increasing time and reducing terminal velocity. Weak forces allow for an easier flow, decreasing time and increasing terminal velocity. Water is polar due to its bent structure and the electronegativity difference between oxygen and hydrogen atoms, resulting in a partial negative charge on oxygen and partial positive charges on hydrogens. This polarity allows water molecules to form hydrogen bonds with each other. The chemical structures of ethanol is the hydroxyl group. This means at the end of the carbon chain there is a functional group of one oxygen atom and one hydrogen atom. This electronegativity difference between the oxygen and hydrogen atoms gives them unique properties, such as the ability to form hydrogen bonds, causing this molecule to be very polar. Canola oil is called triglycerides because it consists of 3 fatty acid units attached to glycerol. The fatty acid chains are mainly composed of carbon and hydrogen atoms linked by non-polar covalent bonds. Although they have a slightly polar carboxyl group at one end, the majority of the molecule is made up of non-polar hydrocarbon chains, giving the fat molecule an overall non-polar character. One could assume that due to the high polarity of water and ethanol, they would exhibit the highest viscosity among the molecules. However, our observations revealed that oil was the most viscous substance. This can be attributed to the relative size of the molecules, as the longer oil carbon chains get tangled and limit the speed at which liquid can flow. This also explains the phenomenon where water was more viscous than ethanol, as the water molecule being smaller could more easily shift and reconfigure than the larger ethanol. Polar substances are generally more viscous than non-polar ones. However, the chemical property of oil having an increased molecular length elevated its viscosity compared to the other fluids. I conclude that if the molecule length for the substances was the same, the more polar substances would have had a higher viscosity than the non-polar ones.